Let's start with the vector algebra. The first point about vector algebra which is important is position vector of a point. Position vector of a point. Now this is given by, let O be the fixed origin. Let's say we have O which is fixed origin, okay, and then the position of a point P is the vector OP vector, okay, this, and it is written as OP vector. If A vector and B vector are position vectors of 2 points A and B, let's say we have 2 points A and B, and A vector and B vectors represent their position vectors, then AB vector will be B vector minus A vector, okay, and this can be written as position vector of B minus position vector of A. Fine. So this is about what this is about the position vector of a point. Now, as this chapter is more of connected with the straight line chapter, so the distance, section formula all will be the same in here. So first of all, the distance formula. Distance formula say that if you have two vectors A, B, right, then the distance AB will be B vector minus A vector. Okay, you just have to subtract. In the case of straight line, we subtract x minus x1, y minus y1, right, and square them and add them and then take the root. This is the distance in straight line, 2 points xy and x1, y1. In this case, you have vectors, not the points, so you will just subtract the vectors and take the mod. Section formula. Now the mod is a different thing here. It is not plus minus something. Section formula now. Section formula says that R vector will be n A vector plus m B vector plus upon n plus m. That is n midpoint of AB will be A vector plus B vector by 2. This is just like arithmetic mean, right? And this is just like we studied in straight lines, that R vector, let's say R is this, A is this and B is this, and it divides it in ratio n is to m. So that is given by n B vector, m A vector, like that. In here we do n A vector plus m B vector upon n plus m. Okay, now we'll move on to the scalar product of two vectors, which is the most basic and important thing about this chapter. Scalar product. Scalar product of two vectors. Let's say we have two vectors, A vector, B vector. If you put a dot in between these two, that will be the scalar vector. It is given by mod of A vector, mod of B vector, cos theta. Now if A vector is 3i plus 4j, let's say, if this is the vector, then mod A vector is this, then mod A vector will be root of this square plus this square. That will be 5. Okay, this is mod. So mod A, which will be a scalar quantity, mod B, again a scalar quantity, cos of theta, angle between these two vectors. Let's say this is A vector and this is B vector. So this is theta, then cos of that angle is the formula for dot product. Mod A, mod B, cos theta. So these are called the magnitudes of A and B respectively, and theta is the angle between A vector and B vector. Now I am going to tell you some important equalities which hold between vectors. First of all, I dot I is 1, and this is also equals to J dot J. That is the dot product of these vectors, I cap, J cap and K cap. I cap is unit length vector. This, let me draw it with another pen, orange. This, J cap is this. This, the modulus of J cap is 1. Fine. This is 1. So this is the vector. Modulus of I cap is also 1, and these I cap is made on x-axis, j cap is made on y-axis, and k cap is made on z-axis, which passes through x and y, which is perpendicular to both of the axes. So that will be your z-axis. It will also be 1 unit. Okay, this is y and this is x. So I dot I is 1, j dot j is 1, k dot k is 1. So like suppose if you have an example, let's say a vector is 2 I cap plus 3 j cap minus 4 k cap, right? And b vector is given to you as 3 I cap plus 2 j cap minus 4 k cap plus 4 k cap. Now you have to do the dot product of these two vectors. Then a dot b will be 2 into 3, 6 plus 6 minus 16, that will be minus 4. So the dot product value will be minus 4. Because I into I is 1, so 2 into 3 will give you 6 only. I into j and I into k is 0. So that's why these two will not get multiplied. Fine. And so you have to just multiply the I vector with I vector, j vector with j vector, and k vector with k vector. So I vector with I vector is 6, 3 into 2. This is 2 into 3, this is 3 into 2, this is 4 into minus 4 into 4. Fine. So this is the method with which you get the dot product. Now another condition, I dot j is equals to j dot k is equals to I dot k is equals to 0. This is important. When we multiplied in the above one, when we multiplied this I vector with this j vector and this k vector, we did not write anything because I dot j is 0 and j dot k is also 0 and k dot I is also 0. So we have to just multiply this I vector with I vector, j vector with j vector, and k vector with k vector. So this is how we do it. Then the next important equality is projection of any vector A vector on B vector. The formula for this is A dot B. You scalarly multiply them and divide by the modulus of B vector, the magnitude of B vector. Okay, this is the projection of A on B. Like if you have this as B vector, this as A vector, then this will be the projection. The value of that is this. Okay, this can also be written as magnitude of A cos theta, where theta is the angle between A and B, because mod B will cancel out. Right? So this is one of the important things. Then we have, if A is equals to let's say the angle phi, the angle cos theta, which was A dot B divided by magnitude of A, magnitude of B. So theta can be calculated by taking the cos inverse of this thing. Fine. Cos theta is this, and theta is always between 0 and pi, because this is the interval where cos is positive. Right. So 0 to pi, cos is positive in first and second quadrant. So cos theta will be 0 to pi. Then if two vectors, if A vector and B vector are perpendicular to each other, fine, then A dot B will be 0, because A dot B is what? Mod A, mod B, cos theta. If theta is 90 degree, cos 90 is 0. So when you multiply 0 with anything, it will become 0. So A dot B is 0 in case we have two perpendicular vectors. Now, and of course, these two should not be 0 vectors. Any one of them should not be 0 vector. Now, we'll move on with vector product of two vectors. Third point, vector product of two vectors. Let's say A and B are two vectors and theta is the angle between them. Then vector product is, first was dot product, then this is vector product. Okay, that one is scalar product, and this is also called, this is called vector product or cross product. This is given by same mod A, mod b is magnitude of A, magnitude of B, sine theta, and n vector, where this is unit vector. That means this is not, this is not written, but this defines the direction of this vector, right? Because when multiplying two vectors, when vectorly multiplying two vectors, we get another vector, not a constant. But in case of dot product, we get a constant. Mod A, mod B, cos theta. That is a constant value. But in this case, you have n vector. That means you have a direction. The product is a vector. And that's why it is called vector product. This A cross B is like, this is A, this is B. Then A cross B will be moving your fingers in this direction, and the thumb will produce in this direction. Okay, so it's like you have these fingers and this will be your thumb. Fine. So you curl your fingers in this direction and your thumb will show you this direction, which is the perpendicular to the plane of these two directions. This will be the direction of your thumb. So okay, so this is your A cross B vector, where this is A vector and this is B vector. Theta is the angle between them. So A cross B vector is perpendicular to both of the vectors. Fine, because thumb is perpendicular to all the fingers. So that's why. This is perpendicular to A and B. So A cross B is perpendicular to A vector, perpendicular to B vector. Fine. And ABC, this is called a right hand screw system. So AB, and this is n vector, because n vector shows the direction of A cross B. So that's why these three forms, these three are in different planes. Okay. Now, geometrically, what does this A cross B tells you? So geometrically, A mod of A cross B, this is the magnitude. This will tell you the area of parallelogram whose two adjacent sides are A vector and B vector, are represented as A vector and B vector. So this is the area of parallelogram. So let's say this is A vector, this is B vector, then you produce B vector in this side and A vector in this side. So this is a parallelogram. The area of this is formed by A vector cross B vector modulus of that, the area. Fine. So this is the geometrical interpretation of this. So if they ask that what does it represent, then area of parallelogram. Okay. Now I'll move on. The next point is I cross I cap cross I cap is equals to J cap cross J cap is K cap cross K cap. All of them are 0. In case of dot product, it was 1. Whilst in case of cross product, I cross J is equals to K and J cross I will be equals to minus K cap. Fine. Similarly, I cross K is minus J cap and J cross K is I cap. K cap cross I is plus J cap and K cross J will be minus I cap. Fine. So you have two K caps, two J caps, two I caps. Fine. So if you are moving in this direction, the nice way to remember this is I, J, K, just make them. If you go in circle in anti-clockwise direction, in clockwise direction, then you are doing it right. But if you anywhere you move from left to right, that is anti-clockwise direction, then you have to put a negative sign, otherwise it is wrong. So like if I is moving, I cross J, so we are moving in this direction. Fine. So I cross J will be from this to this. I cross J will be what? K cap, because we are moving in this direction, which is the right hand direction. Or you can just write right hand and left hand. That will make it easier. So right hand direction, it is positive. If J cross I, that means you are moving in left hand direction. So this is negative. If you are moving from J to K, then this will be positive. Okay, because you are moving in right direction. Then if you are moving from K to J, this is left direction, so negative I. If you are moving from K to I, this is again it is circular but right direction. But if you are moving from I to K, then this will be a negative direction. So these are the things you got to remember, fine. And the dot product, the cross product of these vectors are 0, fine. Now I'll move on to another set of properties. That implies A cross B, how to calculate it if you are given two vectors A and B. This is calculated by magnitude I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. These are all constants, coefficients of vectors, and this will be the representation of vector in the form of Ij and K, because Ij and K represents the direction inside on the axis. So that's why you will get a vector by this method. Now A cross B is this. Again, now if A cross B is 0 vector, this implies that A vector and B vector are parallel, because you cannot curl your directions from this to this vector. Okay, you do not have a pivot end, but in this case you have a pivot end, so you can rotate this vector to this vector. But in this case you do not have any pivot end, so you cannot rotate. So if they are parallel, A cross B will be 0. You cannot cross them. So these are parallel or collinear, you can say, fine. And in this way, if they are parallel or collinear, A vector can be represented as a constant into B vector always. This is a scalar quantity, fine. Now move on. A unit vector perpendicular to the plane of A vector and B vector is n vector, n cap, right? We learnt it. So it is given by A vector cross B vector upon mod of A vector cross B vector, and plus minus you can write anything, because the thumb do not tell the direction. So unit vector perpendicular to plane of A and B. If this is the plane made by A and B, okay, say this is A, this is B, so perpendicular to these will be two directions, so plus and minus. If this implies plus, this will imply minus, and this n cap can be anything of these, A cross B upon mod of A cross B. Now this is unit vector, so n vector. Now if A, B and C are three position vectors of 3 points A, B and C, and the vector area of triangle ABC is triangle ABC, the area of this triangle, vector area of this triangle will be half A cross B. That means you are given A vector, B vector and C vector, all three position vectors of points A, B and C, fine. Then how do you calculate? So you will first cross product of, you'll find the cross product of A and B, that is A cross B, then you'll add it with B cross C, then you'll add it to C cross A, fine, and you'll do the half of that. Then you'll get the area, vector area of the triangle ABC. And if you want to know that they are collinear, then this area should be 0 if they are collinear, fine. Now the next point is the Lagrange, is the area of quadrilateral whose diagonal vectors are d1, d2. So let's say you have a quadrilateral and you have diagonal vectors d1 vector and d2 vector. So you can always do the rotation, that the area will be half d1 cross d2, because d1 cross d2 implies the area of parallelogram. So half of that will be this area of quadrilateral. Half of this is the area. Now the next point, which is also important, that is the Lagrange equality, like Lagrange identity, we tell it. Lagrange's identity. This says that A cross B, if you have two vectors A cross B, then their square will be equals to A square mod of A vector square into mod of B vector square minus A vector dot B vector whole square. or it can be written as A dot A dot B, A dot